attention. All right, so your homework was 62 through 72. So what I'm going to do, I know there's a couple I absolutely want to go over, and then some that people might have questions about. But we can start right with 62. They did accept a couple of answers. I wrote Mariana Trench. You could have just went with trench. You could have said mountains. You could have said volcanic arc. Any of those. Does anybody put anything that's not Mariana Trench that you're not sure will work? Okay. 463, I do want to explain this one. So they did say, question 63 says, identify the names of the subducting and overriding plates at location B. So I find location B, it's up here in between North America and the Pacific plate. So I matched that up with my reference table, and they asked which one's subsiding and which one's the overriding plate. And it's actually really easy to tell. So this is the area that this map was talking about for B. And the way you tell, so again, the arrows are pointing together. And when plates collide, they can do a couple of things. They could either both go up or one goes down below the other. And to tell which one's going above and which one's going under, you have to look at those boxes on the line. So you find, and it's right here in the key. So see how one side has the boxes, the other side's kind of like a blank line. The side with the boxes is the overriding plate. So in this case, the boxes are on the North American plate and the blank side is the Pacific plate. So for that, and you did have to have them in the correct order. The subducting is the Pacific, the overriding is the North American plate. Then 64 asked, what is that what did it say? I'm actually lost. 64 at C, which is right down here underneath the Nausicaa plate. That is the East Pacific Ridge. And then they asked what's going on at D, which you can see is a little bit southwest of Australia. And right there, that's a transform plate boundary. So again, 63 was Pacific plate, North American plate, 64 East Pacific Ridge, and 65 is a transform plate boundary. Questions so far? Okay, with 66, I double checked the grading key. So I think I've mentioned before that they're really picky on how I grade, and they specifically say nope, I did not keep it up here. They give me, basically I put a clear copy of their answers over your answers to see if your bars go up to the right spot. They did give you about half a box of wiggle room. So if you were off by a little bit, it's okay. But the major part of this was just figuring out that the lines went up by 2. So what I mean is 0, 2, 4, 6, 8, 10, 12, 14, 16 for the first one. So this one should have been up to 16, 14. Was this one 25, I think? 25, 38, and 7. For capillarity action, when we go from fine to very coarse, and this is just size of the sand. It's just asking which one does the water go up higher. Capillarity is the upward movement of water. I remember that's best with little ones. So the smaller the particle, the more capillarity, and it goes down. Only acceptable answer would have been that. They did accept like a slightly curvy instead of a straight line, anything that was just a down. And then number 68 was 5 to 6 centimeters. So if you had 5, that's fine. If you had 6, that's fine. Something in between. Every other class has had me go over that one. Do you guys want me to go over that? Or did you get that answer? No, just 5 or any answer from 5 to 6. But they did give you a little bit of wiggle room. So real quick, they said a particle diameter of 0.1. You go over till you hit the line, go down, and it does. To me, it looks like it hit right at 5. So I'm surprised they gave you that wiggle room. But in case you made a mistake, they accepted anything from 5 to 6. On the last couple, this one was a little weird. So your X had to be somewhere over here. You did only have to put 1, not the 5 that I put. So why it goes over there is they wanted, how did they word it? They said, the greatest difference in age. So we know that this layer of sandstone is younger than the unconformity. How do I know, by the way, that this, however you say this, sandstone is younger than the black unconformity? That was a question. How do I know the sandstone's younger than the great unconformity? Uh-oh, guys, that's the actual question. Because it's what? What's lower? Which one's the unconformity's lower? Yeah, that's it. So I would have said it the other way, but that works too. So we know that this sandstone is younger than the black line, which is the great unconformity, because the sandstone's on top of it. We want the greatest difference in age. So we really want to put an X where it's the very oldest layer touching it. So over here, these layers are all tilted. What do you know about tilting? When did they tilt? Uh-oh. Were they always tilted? No, they got tilted after they were formed. So really, if you guys remember when I had you do this, I had you kind of untilt it in your head. Now I can untilt it. I know it makes it kind of awkward, but when I untilt it, I see that this sandstone layer would be the youngest out of all these tilted layers. And this, out of all the tilted layers that are touching that unconformity, this, and I don't know how you pronounce this, Venetiu maybe, it's the absolute lowest, so it's the oldest. So over here we have the youngest rock touching the oldest rock right here. All these other layers have been worn away by the unconformity. So again, over there. Number 70, you could put any two of these. I just put a whole list. They asked, how does an unconformity form? So an unconformity, remember, is a buried erosional surface. So I put, most of you probably put weathering and erosion as your two, but any two, weathering, erosion, uplift, deposition, burial, there were more. Anybody not sure if their answer is good enough? Okay. How do we know that A is younger than the line BC? Again, you could have put a bunch of different answers. You could say A cuts through the unconformity. You could say that A was not broken by the unconformity, or A was not removed by the unconformity, or you could say an intrusion is younger than any of the rocks it goes through, anything like that. Again, anybody want to check their answer? I knew it was going to be quiet in here today. Then they asked how the schist formed. And again, schist is a metamorphic rock. So I'm guessing most of you said heat and pressure. You could have just wrote heat or pressure or just metamorphism. Anybody have a question on any of those 10 homeworks? No. Okay. So then before we get started, I do have homework up there for you tonight. So just in case we run out of time, I want to show you what your homework is. So it's not in that test booklet. It's in your actual booklet. Or your actual packet, I should say. So the page numbers got all messed up, but we can figure it out. This page that we worked on all last week, this is page 21. So why don't we all start there? Go to page 21. And then the page on the back of that. So find page 21. So this one with the moons on it. I think it's before that page. I think you're going the wrong way. Keep going. No, it's gotta look like this. Oh. Okay, that one. Yep. So if you haven't already, I would have labeled this one that we worked on the moon phases. That's page 21. The back of that page, which everybody else would normally think that's page 22. It's not. It's 21 and a half. So this is the page we're going to be doing our notes on, by the way. So turn the page and label it 21 and a half. Then the next page, which you can see is labeled 22. Then the back of that page. is labeled both 23 and 24. I don't know why, how that happened, but yes, this page is for homework. So page 23 and 24 are for homework. Then when you turn this page, you can probably see that that does say 25, but the 5 did get cut off. So this is also homework due tomorrow. And then the next page, if you can imagine, after 25, this page is 26, which is also homework. And then 27, which is also your homework. So I know it sounds like a lot of pages, but it's only 17 questions. And I plan to give you 5 to 10 minutes here at the end of class. We'll see how far we get though. Last class had 5 minutes, the class before had 10. So hopefully we can get through. So that's your homework in case we are rushing at the end, but I don't think we will be. Now what I'd like you to do is go to the brand new page 21 and a half. It says eclipses of the moon. And just so you know that once I get to the PowerPoint, everybody see where it says lunar eclipse? And then this picture, right here is where our notes are going to start. I know, again, I don't know why I didn't just start at the top, but this is where we're going to start our notes, right underneath lunar eclipse. So let's start with, do you guys know what an eclipse is? Have you ever seen one?
Yeah.
Yeah, you guys, whatever grade you were in, or whatever you were in 6th grade, that's when it was. We figured it out this morning. It was the summer before COVID, so it would have been the 2019 would have been the year that there was one in middle to early August. It was, do you guys remember, was it a solar or a lunar eclipse?
Solar.
It was a solar eclipse. So to start off with, I should say that an eclipse is named for what gets blocked. So if the sun's getting blocked, that's a solar eclipse. And if the moon's getting blocked, that's a lunar eclipse. So that's really how you figure out which one's which. There will be, so if you actually, let's go back to summer of 6th grade, or summer after 6th grade, I think that would have been, right? And not important. Do you guys remember what it looked like? Did anybody watch it?
Yeah, I went outside.
It was a little bit weird out. Now, did you have the glasses to look up at the moon or sun? Did you look in them?
I didn't.
Okay.
It was weird. It's like it had to
Yeah, so what happened was the moon's shadow covers up the sun. And in our case, we didn't get what's called a full solar eclipse. It was only part of it. So it almost kind of looked like the sun was doing like a phases of the moon type thing. This coming April, so a little bit less than a year from now, April, I think it's 24th, but don't quote me on that. Sometime after school, I think it's 2-ish, we will be in the path of a total solar eclipse. So our little area of Western New York will get to see a perfect solar eclipse next year. Completely dark, like nighttime, which is freaky. I've never experienced it, so I'm really looking forward to it. The only dilemma is, what do you guys know about our weather in
cloudy?
Yeah. So typically our weather in April is so we do have a chance of it being yucky and cloudy, and we might not get the full effect, but in the end, the sun is still going to get covered up. So even if it's cloudy and yucky out, it still will become dark out like nighttime around 2 o'clock and then go back to being light out, which is really weird to me. So even if it's cloudy, we'll still get the effects of it. Yeah.
How long?
I honestly don't know how long it takes, but it is. It's April of next year. April of 24. So maybe that's where I'm getting the 24. I don't know the date off the top of my head, but it's April. It's right after our Easter break. It's the Monday after Easter break next year. That I do know. And it's sometime right around when you'll be getting on or going home. So getting on the bus or going home. But the science department, we're going to remind you a lot about this next year. We're trying to get administration to let us do an assembly and talk about it, make sure you know what's going on. Cause it's going to be cool. It's literally,
I won't be attending that.
Yes, you will, Sam, because I'm going to make you.
How can you make me?
Because I'm the boss of you. That's why. Anyway, it is literally a once in a lifetime. I'm 41 years old. I will be 41 years old by then, and we'll have never saw one. So I think it's pretty cool. But anyway, let's do these notes so we can be done with the year tomorrow. So we're gonna start with, like I said, we're starting at that weird spot that I was pointing to a minute ago. Why are we not moving? Here's a lunar eclipse. So like I was saying, they are named for what gets blocked. So during a lunar eclipse, this happens when the moon would have been in the full position. So again, it's a lunar eclipse, so it's the moon getting blocked. You can only have a lunar eclipse when the moon would have been full. So on my model up here, it would only happen when the moon would have been in this position where the moon would have been a full moon if it could see the sun, but the Earth's shadow covers it up. So unfortunately, I think we're at that time of the year where you're like, okay, Mrs. Rick, this is great, but what do I need to know for the region? And maybe you were there all year, but now I'm just admitting it. What do you need to know for the regions? You need to know that they are named for what's getting covered up. So that's the first thing. Lunar eclipse means the moon is getting covered up. Lunar, moon. And then the next thing you have to do is if I show you a picture, which I'm about to do, you have to decide, is that a solar or a lunar eclipse? Did everybody get these 3 bullets or not quite yet? Okay, give me a second. Okay, so here's the picture I was speaking of, maybe. Here's the picture. So in this case, first of all, what do you think the big circle, and this is the same picture you have in your notes. What? Yeah, the big circle's the sun. If you did not, if that didn't process immediately, go ahead and label it. So the big circle is the sun. What do you think the medium circle is? Okay, again, if that did not occur to you, label it. And the little guy, that's the moon. So you have to be able to see a picture of the Earth, sun, and moon and decide, is this a solar or a lunar eclipse? And again, it's just what's getting blocked or what can't you see because it's all dark. So again, how you do that, I suggest if you say, okay, here's the Earth. If I was standing on the Earth, is there anything obstructing my view of the sun? Is there in this picture? No, sun's in full light right there. Now, if you're standing on the Earth and you're looking at the moon, is there any reason you wouldn't be able to see it? And in this picture, you can't see the moon. Even though it's there, you wouldn't be able to see it because the light's getting blocked from the sun. So this is a lunar eclipse when the moon is not getting any light from the sun. Again, because the Earth's shadow is in the way. No?
You can't really see it.
Yes, but it's not able to get to the moon because, like, see, look at this guy right here. The Earth's in the way. Yes, but it still can't get any of the light. The moon is behind the Earth and the shadow. It's not even at so the sunlight, yeah, it's gonna go over here, but it can't get to the little tiny moon. We're trying to light up a little tiny thing that's in in the moon, Earth's shadow, in the Earth's shadow. So then we switch over to a solar eclipse. Actually, before we do that, no, I don't like this picture. Never mind. Let's go to the solar eclipse. So a solar eclipse, this happens when the moon is in the new position. So again, that would be in this case. So the moon's shadow moves over the Earth's surface and blocks the sun. So it's not really the moon itself that's blocking the sun, it's the moon's shadow is casting a shadow onto the Earth so that the Earth can't see the sun. So again, what do you need for the regions? You need to be able to acknowledge that solar means the sun is getting blocked. And then we'll look at the picture that's down below where you're writing. And we can see that in that picture, it's the sun that's getting blocked. But in this case, because the sun is so large, so this kind of goes to what you were talking about. If you were standing on if you were here on Earth, you can see kind of around the moon's shadow. So it only affects the people right there. Out of the whole Earth, it will only be a total solar eclipse for this little section of the Earth, which is why I'm kind of making such a big deal over the solar eclipse hitting us next year, because we are just in that very small section. Very few places in the United States will see that total solar eclipse next year, but we will see it perfectly because we will be timed perfectly to be right there, which is pretty cool.
How big do you think that could be?
I can pull up a map and it shows let's just do that now. Because it's cool. It is super cool. I don't care what you think. Solar eclipse. Okay, April 8th. There you go. No, it was last time, yeah, because my brother had it in Oregon. So it's that much. What the freaking heck? What do you mean it's all blue up there? Why?
It was as if it was just
Get up, Sam. Oh. There you go. So just this small path are the people that will see the total solar eclipse. And it's actually what? No, last time it was.
I thought the next one was supposed to be in like 84 years.
No, maybe for those people who saw it last time, maybe. But for us, so you can see we're right there in this section right here, Buffalo. So we'll be in total darkness for 3 minutes and 45 seconds.
It's kind of freaky.
It is cool, Henry. I'm super excited. All right. It's cool. It's something I've never seen.
Probably gonna be sleeping.
You better not be.
Oh, who knows? I don't know what I'm gonna be doing a year from now.
Well, it's less than a year from now. All right, so that's eclipses. So again, what do you need to be able to do? You need to be able to identify them as a solar or a lunar based on what's getting blocked. So in this case, which one is this?
Lunar.
Lunar, because again,
Because the Earth
can you see the sun?
blocked it.
Totally can see the sun, but the Earth is blocking them. The Earth's shadow is blocking the moon. This one is the solar eclipse because you can see the moon, but it'll be blocking the sun, some of the sun.
So lunar eclipse is way more common.
Yes, lunar eclipses are way more common. All right.
Way more predictable.
They're all predictable. You'd have to like do math and stuff, but they're all predictable.
Yeah.
All right, so we're gonna move on to tides. What do you guys know about tides?
No, the moon.
Okay, so we know that the tides are controlled by the moon. Some of you did. You did.
Learned it from the Avatar.
Where do they occur? Ocean, not on lakes, not on ponds, not in rivers. They only happen on the ocean. I have a quick video of a tide. So if you've never experienced it, actually, let's go back. Any of you who have experienced the tide, can you describe it?
Actually, yeah,
Sam's got it.
well, I don't remember it great, but when I was in Costa Rica, there was like certain times of the day when the tide would be higher in, so like there was one spot on the beach where you come at one point in the day and covered in water, and then next point in the day you come back and it'll be completely sand.
Exactly, and that's a perfect description. And you can't so people who live there, they have it timed out and they know exactly what's going on. But those of us who just visit, we just go one day, we put our stuff down. If you then either go for a walk or go out and play in the water, if you put your stuff down, either when you come back, there's going to be a lot more beach between your stuff and the water, or your stuff's gonna be completely underwater because the tide has come in and is higher up the beach. For those of you who have not seen it, I have some extreme versions or extreme cases here that I do want to show you. We're gonna go back to here. You'd think by now I'd be good at this. Quiet you. All right, here is what's called the Bay of Fundy. This is the most extreme version. You can see how high these boats are in the water right now. It's like a little harbor where they're parking their fishing boats. Notice the water level going down, like somebody pulled blood on this bay. And watch how low the water is. These boats are now coming down. Water, and now they are all sitting on dry ground. Some places, or you can imagine, like, you can't go anywhere, and they decide to check in, and when it comes back in, you'll see again exactly how high it goes. There are 12 hours between high tide and the next high tide. That was a 6-hour time lapse you just watched there from when it was at its highest to its lowest. So it happens twice a day. There's 2 low tides a day and 2 high tides during the day. I was hoping this goes to the next. What's it gonna show? What's it gonna show? Let's see. All right, forget it. Okay, so that one I don't want to show. Oh, here is, I don't know where this one is, but here is a very, very low tide. Notice how far out that is. Watch when it comes in. So this is what Sam was saying. You could be sitting here, you could come out sometimes and it's completely dry. And then, just watch. So you can see it's kind of creeping up here. That's 6 hours between the lowest low tide and the highest high tide of the day. I find it fascinating. I don't know about you guys. But it gets up pretty freaking high for high tide. Yeah, it was all the way out. I think the dock might not have even been it. I should, we'll watch it go out, I think. You could, oh, no, it didn't. But you could see, oh.
Lock in.
What? So just look at the beginning of that again, just to. So you could, yeah, it was all the way out by the dock. You can see that this was a pretty angled down, and by the end of it, it was almost like the walkway was going up a little bit. Pretty fascinating to me, especially since it's the moon that's doing this. The moon is the reason we have tides. How can the moon control tides? Let me think. Somebody always answers my question with this answer, and you're always wrong every other time.
With tidal waves?
Nah, no. Gravity. So the moon has gravity. Do you feel the moon's gravity right now?
No.
Anybody being pulled towards the moon? Why are we not being pulled towards the moon? It's not because water goes in. What? Earth has gravity. Why are we being pulled to Earth and not to the moon? Okay, one is because we're closer to Earth. Clearly we are closer to Earth. I'm standing on Earth. What's the other reason Earth is more powerful gravity than the moon? A couple weeks ago. Another reason Earth's gravity is stronger than the moon's. One, we're closer, one,
Bigger?
yeah, Earth is a lot bigger. So we do not feel the effects of the moon's gravity. But when we start bringing in individual water molecules floating around in the huge oceans, again, this only affects the ocean, those water molecules can feel the moon's gravity a little bit. And what happens is the water in these huge oceans gets tugged a little bit by the moon, creating, when it's tugging it towards it, it's gonna create the high tide. Now, if I'm pulling the water from one place, not like I'm just adding more water to that place, what's happening somewhere else? Yeah, it's going away somewhere else. So it's not like I'm just adding or removing water, I'm just changing that water's position. So whenever there's a high tide somewhere on the earth, there's a low tide exactly opposite or parallel or perpendicular to that. Let's get these notes up real quick and it should be pretty clear. So tides, right on the top of page 22. Tides are the rising and falling of ocean surface. So just like we saw in those videos, the water comes up, the water goes down. It wasn't a wave. It wasn't a tsunami, but if there happened to have been a tsunami during a high tide, you could see that that would cause way more damage than if there was a tsunami during low tide, especially that last one. If it would cause way more damage when the tide is higher up. In fact, the hurricane that hit New York City not too long ago, I think might have been Hurricane Sandy, but I don't remember. It happened during a high tide, which caused way more flooding than there would have been if it happened during a low tide. So again, what is the Regents going to ask you about tides? Is they're going to ask you to figure out where the high tides are on Earth. And the best explanation I can have for you is the high tides always follow the moon. So wherever the moon is wherever the high tides are going to be. So notice on this picture, the H's are lined up with the moon. Notice on the second picture, when the moon has shifted positions, because we know the moon goes around the Earth. So when the moon has shifted positions and it's up here, again, the high tides follow the moon. They're always in a straight line with the moon. There is one more thing about tides that the Regents is going to ask you. And that's when, notice in this first picture, see how the sun and the moon are lined up now? Well, what that does is has the sun gets in on the gravity action. So when the sun and the moon and the earth are lined up perfectly like this, it enhances the gravity. Because now we've got the sun and the moon working together to make more gravity. So if there's more gravity, what do you think's happening with the water and the high tide?
Bigger and lower tide.
Yes, higher high tides and lower low tides. Because when the sun gets in, it's like it's pulling that high tide farther over towards the moon, making the lower tide even lower than normal and the higher tide higher than normal. Versus over here, we'll still have high tides lined up with the moon. They just won't be as high as they would have been in this position. So I'm guessing that last video that we just watched was when the earth and the moon and the sun were in this position, pulling all of that water way up onto that beach. So one last thing to put into our notes, and we're not going to put everything. So you have this same picture in your notes, right? What I'd like you to do, you have a big blank space here. Take that line that separates the two of them and just go up. So we're basically making a T-chart. So one side is going to be notes for this picture, and the other notes are going to be for the other side. So you're basically doing this, but we don't need to copy all of this. So one thing we need to do is we need to copy the title. So the picture on the left, that's a spring tide. So write that in. So it's spring, not like the season spring, but spring like a slinky, you know, that you could stretch it out really far and then push it back in really close. That's what they're talking about. That's what I want. I want this first bullet and the third bullet for spring tide. It occurs when the moon and the earth are in a straight line with the sun. So when everybody's lined up, you'll always have really high tide. And the lowest low tide. So just get those two bullets. Same with the other side. Get the tidal. So this other one, when you still have high and low tides, they're just not super high and super low. That's called a neap tide. And again, get the first and the third bullet into your notes. Then when we're done with that, I'm sorry we didn't have a chance to start your homework. But that'll be it for the day. And remember, you have homework. Questions 1 through 17. It's all about the moon. Moon phases, eclipse, and tides. So don't forget to do your homework. I can put this up again at the end of class or at the beginning of class tomorrow if anybody needs to copy it in.